6 of Chapter 2, Subtopic Trapezoidal Rule. The learning outcomes of this lecture: students should be able to use the trapezoidal rule to approximate definite integral. So let us take a look on these two graphs. The first graph shows the shaded region under a curve, while the second graph also shows the shaded region. But now this shaded region is divided into several strips between point A to point B. If you notice here, each strips there is a width for each strips. So you can calculate the width for each strips by using this formula. We denote width of each strip by using variable h. So the formula is b minus a, where b is the ending point and a is the starting point, divided by n. N is the number of strips that you have between point A to point B. Let's moving on. For n plus 1 ordinates, there are n strips. This is very important. You need to pay attention. This is for future reference. If 6 ordinates, then it's referred to 5 number of strips. If you notice here, different terms used in the questions refer different number of strips. If the question use ordinates, then if 6 ordinates, then number of strips is 5, okay, are 5. If 6 subintervals, then number of strips are 6. And lastly, if the term used is strips, then the number of strips are 6, obviously. So you need to memorize these 3 terms. Different terms used in the question refer to different number of strips. Alright, so the area under the curve is approximately equal. So you need to pay attention here. It's not really equal. It's approximately equal to the sum of the areas of n trapezium. Okay, so we already know this is the formula for finding area under a curve, integral a to b, right? So it is approximately equal to the sum of the areas of n trapezium. Okay, this is a derivation of formula area of n trapezium. This is the derivation, but the most important part that you really need to know is the last part. Okay, in the red box here, this is very important. You need to remember this one. So integral a to b for function of x dx is equal to this formula, h over 2, where h you already know it is the width of the strips, where h is equal to b minus a over n. And those at the back are the formula. I can explain it more in the examples. And lastly, I want to explain about error. Okay, what is error? Okay, as I mentioned earlier, sum of the areas of n trapezium is just approximate value for area under a curve. It is not an actual value. So the little difference between approximate value and actual value, we call it as error. So the question might ask you, what is the error between approximate value and actual value? So you can use this formula to find the value of error. Approximation value minus the actual value and put them in the modulus. So you're going to get the positive value. The question might also ask you about percentage. So you just need to change the value to percentage form. So that's all you need to know about trapezoidal rule. So let's move on examples.
Use the trapezoidal rule with 5 ordinates to evaluate integral of exponent x squared dx from 0 to 0.8. Give your answer correct to 3 decimal places. So 5 ordinates, so meaning n equal to 4. So h equal to 0.8 minus 0 divided by 4. So we have 0.2. So we have the table here. So this is your xn. So this is your yn, which is the function itself, which is exponent of x squared. So we start off with 0. x0 is 0. So x1 is 0.2. x2 0.4. x3 0.6. and x4 0.8. So the last row will be total. So press your calculator. So this is 1.000. So we want 3 decimal places. So you give your values in your table during workings to 4. You need to give it extra 1 decimal places. So this is y0. Okay, this is y1. So this is 1.0408. y2 1.1735. y3 1.4333. And then y4 is 1.8965. So you add up. So here you get 2.8965. And here you get 3.6476. So hence, integral from 0 to 0.8 of exponent of x squared dx equal to half times 0.2, which is the h, and 2.8965 plus 2 times 3.6476. So we have it to be 1.019 to 3 decimal places. Using the trapezium rule with 4 sub-intervals, calculate the approximate value for the area under the curve of fx equals to ln of x plus 1 between x equal to 2 and x equal to 4. Give your answer to 4 decimal places. So 4 decimal places, 4 sub-intervals, so n equal to 4. So your A will be 2, your B 4, your N 4. Okay, so H will be 4 minus 2 divided by 4. So 2 over 4, so we have half, 0.5. So plot the table. So this will be the values for your x. This is value for your y. So y equal to fx. So our fx is ln of x plus 1. So x0 will be 2, x1 will be 2.5, x2 3, put it 0 there. So x3 is 3.5, x4 4. So this is total. So now press your calculator. So use the table. Okay. And then you can simply write down, copy down the value. So we want 4 decimal places. So inside the table should be 5 decimal places. So this is 1 point, this is y0. So this is 1.09861. So this is y1, this is y2, this is y3, y4. So y4 is 1.60944, 4 decimal places, 5 decimal places. So this is 1.25276, 1.38629, and 1.50408. So you total up the value. So here we will get 2.70805. So here will be 4.14313. Then we use the formula. So integral from 2 to 4 of ln of x plus 1. So that is equal to half of h 0.5. So the total to 2.70805 plus 2 times 4.14313. So press your calculator, so we will get 2.7486 to 4 decimal places.
Example 24, given that t is equal to 0, integral 0 to pi over 3, tan x dx. First question asks you find the value of t by using substitution method. Give your answer to 4 decimal places. So remember, your final answer must be in 4 decimal places. So in order to undergo substitution method, what you need to do is the first step, you need to change term tan x to sine of a cos. And then what you need to do next is let cos x to u. So write down here, let u equal to cos x, and then find your first derivative, differentiate u in terms of x. You're going to get negative sine x. Alright, so cos x here, you can substitute as u. So what you need to do now is you need to find out what is sine x dx in variable in terms of u. So where you can get this is from your first derivative. So make sine x dx here as your subject. It is actually equal to negative du equal to sine x dx. So you can simply substitute sine x dx as negative du and substitute cos x as u. So now you need to write down properly. So it is equal to, put your negative sign outside the integral. So 1 over u du. Integrate 1 over u in terms of u. So integrate 1 over u is actually equal to ln modulus u. Remember, if you integrate, must put modulus if you get ln. And make sure plus c. Okay, because we don't have the value for variable u. We have just now the value for variable x. So for now, you need to plus c first. And then after you substitute it back to terms x, so u is actually equal to cos x, right? So you can simply remove the c, and then you have to write down the value of a and b. So your a is 0 and your b is pi over 3. Show the substitution of the value. So negative ln cos pi over 3 minus negative ln cos 0. It is actually equal to 0.6931. So this is the value of t. Alright, now let's do for question B of example 24. The question asks you, use the trapezium rule to estimate. See the word here, estimate. So estimate meaning the approximate value. The value of t with 4 strips. So the term used is strips. So you automatically know n is equal to 4. Correct to 4 decimal places and find the percentage error. So now the first thing first, what you need to do is find the width of each strip. So the formula is h equal to b minus a over n. So your b is pi over 3 minus 0 over 4. So it is equal to pi over 12. So you know the width of each strip is pi over 12. So your starting point is 0 and your ending point is pi over 3. Alright, so add on pi over 12 for each strip. So you're going to get pi over 12 here and pi over 6 here and pi over 4. Okay, your y is your function itself. So your function is tan x. So what you need to do is just simply substitute your x into your tan x. Okay, so you're gonna get the value of y. So the question asks you, your final answer gonna have to be in 4 decimal places. So first of all, you need to make at least one more decimal places. So make it 5. All right. So the first one is 0.00000 and so on. Just use your calculator to find out the values. Okay, you can also use menu number 9. You can ask your tutor lecturer, to explain how to find the values using calculator. 26795 0.577 35 1.00000 and lastly 1.73205. So total up everything, you're gonna get here 1.73205 and for this part 1.8453. Okay, so you already have all the information. So now you just need to put everything into the formula. So integral 0 to pi over 3. So your function is tan x dx approximately equal to the sum of trapezium. So the formula is pi h over 2. So your h is pi over 12 over 2. And then this one 1.73205 plus 2 times the second total 1.84530. Okay, so simply press your calculator, you're gonna get 0.7098. Make sure your final answer 4 decimal places. Alright, so this is the approximation value, and then the question continue, find the percentage error. So you need to find out the error first. Error is equal to approximate minus the actual value. So approximate value is 0.7098. The actual value is from part A, 0.6931. So the value is 0.0167. Okay, so the percentage error is equal to 0.0167 divided by the actual value 0.6931, and don't forget to put it in the modulus form, and times 100. So the percentage is 2.41%, very little. Alright, so that's all for example 24.